Okay, so I'm going to do a little recap of the exponential basic function and showing how we're going to solve for the x and for the y. So basically, we're going to just start again with the basic function. Now I know that in Math Help Services, they showed the basic just as this with the c. I'm adding the a, and then we'll talk again about the b today. If you did watch the other video, I talked about a little bit about what the b does. It's a period of time. Today we're just going to go over some basics just to make sure that you guys know how to use your log buttons on the calculator and how to use the exponent buttons. Okay, so starting off with the basic exponential, we're going to go into learning how to solve for the x and learning how to solve for the y. Just going to quickly recap. So here's an exponential function. I have an a of 20, c of 1.05, which later on we're going to learn about compound interest, and this is how you would show compound interest. And we have the exponent of x. So if you want to solve for y and x is given as a 5, you make sure that you do order of operations and you apply the 5 first. So you're going to go on your calculator and do this calculation first using the xy button, or y to the power of x. So it would be 1.05 to the power of 5, and then you multiply it by the 20. So your answer should be 25.52, and recurring, it goes 5, 6, whatever. So just the important concept is that you do this first. Now we're going to move on to the more complicated part, which is solving for the x, which is solving for the exponent. So here I'm giving you another equation, and this time I'm asking you to solve for x by replacing the y by the given value, which is 1,000. So you're going to put your 1,000 here. You still rewrite your equation as is. And now you need to isolate the base. So this is considered the base. You need to get rid of that 20. So we're going to divide both sides by 20. This cancels out. So you have your 1,000 divided by 20, which makes 50. And this is what is the most important part that you need to do. So you're going to now rewrite it as a log. So when you're at this point and you have no idea what to do, the only way to solve it is, well, you could do trial and error and sit there and go with your calculator and go 1.05 to the power of what gives me 50. It's not going to be very helpful. So I ask you to rewrite it as a log, which is going to be like this. So remembering, this is your base, this is your exponent, and this is your power. You're going to rewrite it like this. Log the base on the bottom, the power over here, equals x. Now what does this mean? This is a notation, if you remember from the last video, of how to solve the exponent. Now what does this mean in terms of you calculating? If you don't have your fancy little calculator, you're going to actually go log of 50 divided by log of 1.05, and then you press your equal sign. I'll do that on my calculator at the same time. 50 log divided by 1.05 log. So you have to figure out which way your calculator works. Does it put the log first, or do you put the number first? So it's 80.18 is equal to x. And that is basically how you solve for x and how you solve for y. Of course, if you want to check your answer and you want to see if that is correct, all you have to do is say, well, let me see. Check my answer. Is 1.05 to the power of 80.18 going to give me approximately 50. 1.05 to the power of 80.18. Yes, it does. It gives you 49.99 because I didn't use the full decimal. It gives you 50. And of course, I'm using this button right here on my calculator, or on some people's it looks like this. And some people don't have that. They have this button over here. Okay. Now that is for how to solve an X and Y. Quick recap of what it is to use logs. The next thing I want you guys to know is, I think I'm missing a page. Give me a second. We're going to work with negative exponents. I'll do this one first. Okay. So the first thing we're going to do is we're going to find out how to find the rule using this button here. So supposing I give you an exponential function in graph, and I've given you the x component and the y component. I've given you these coordinates, and I say find the rule. Well, all you have is this, which is the y, so it's 1,296, and you have the x, which is 4. So basically, you're going to now need to get rid of that 4. You have to isolate the c. In order for you to isolate the c, you're going to use this button up here that I've circled in red. And you often find it on the top of the yx button or the exponential button, and you need to use shift or second function. So you make sure you know how to use your calculator because every calculator is different. So you're going to now put the opposite of a c to the 4 would be like this. What you do to one side, you do to the other. And of course, this will cancel that out. But then on your calculator, you're going to use, I press 4 first. Then I press the shift button. Then I press this button. And then I press 1296. You figure out on your own calculator what it is. And that gives me 4 shift, this button, 1296. Maybe I did not do that right. Let me check again. Shift 1296. So in my calculator, I was supposed to actually do the other way around, 1296, shift 4. Anyways, whatever you do, you need to get the answer 6. So 6 is equal to C. Now to check, just do, is 6 to the power of 4, is that equal to 1296? Yes, it is. 6 to the power of 4, 1296. So very important in figuring out how to solve using your own calculator. So make sure you've done that. Shift 4. Yes, so in my calculator, actually, it was the other way around. I had to do 1296, shift this button, and then 4, and that gave me 6. Okay, moving along. We're going to talk about negative exponents. A little quick recap. Negative exponents, if you remember, it's represented like this. So 5 to the power of negative 3 would be the same thing as writing 1 over 5 to the power of 3. So if I have a variable, c to the power of negative 3, it would be the same thing as writing 1 over c to the 3. This is going to become important when we're solving and trying to find the rule. So I'm going to move on to the next question, which I've taken from your skill builders. I think it's page 305. So if we look at this question, I believe it's something like 305 in your skill builders in your workbook. It asks you for finding the rule. If you notice, they're not even giving you an A. They're telling you that the rule is the basic rule. So in the basic rule, you don't have an A because they told you you don't have an A. So you still have to figure out the C, but you have a negative. So how are you going to do this? So you do this by replacing the values that are here, because you know this is your X value and this is your Y value. So your C is going to be -3. Now, yes, you can do this straight on the calculator, but I really need you to understand that this is the same thing as writing 1 over C to the power of 3. And if you were to solve this, you would cross multiply, so it would be 125C3 is equal to 1. And now you want to isolate that C3, or C cubed, so it's 1 over 125. Now how do you get rid of a cube? You cubic root it. And what you do to one side, you do to the other. So of course, this will cancel that out, and now your C is isolated. And I could do this in my head because I know that the cubic root of 125 is 5. But if not, of course, you can use your calculator. And there's my final answer. So your final equation would look like this. Y is equal to 1/5 x. And that's your answer. So that is for finding a rule when it's the basic c to the power of x. We're going to now move on to finding the rule when they say so I'm going to call this how to find the rule. Of course, you can pause this video at any point in time, or you could speed me up and put me in speed, I think, 2. It's probably more interesting when I'm at a faster pace. All right, so here you have a table of values. You can go ahead and graph it if you like, but it doesn't really matter because the whole point is for you to figure out what the rule is. Now I want you guys to remember that if there is an A, an initial value, and they're telling you the B is 1, so there is no B basically. So since there's no B, you could easily figure this out. Now, there's 2 versions of finding the rule. The first version is that you are given when x is 0. When x is 0, if x equals 0, that means when your exponent is 0, your answer is 1. So in this case, when you see that, it's super simple because you'll figure out that your initial value is 12. Why? Because, look, you put the 12 in this position, that's the y. You put the a, you don't know it. The c to the power of 0 makes 1. So a, all of this right here, this makes 1. So 12 is equal to a. And that makes sense because if you look at the other ones, so if you look at 136, so we know our equation is 12 and then c to the power of x. All we have to do now is plug in what the values are. So let's plug in another point, 1 and 36. So you're going to do 36 in the position of y, 12, c to the power of 1. Well, you need to get rid of the 12. 36 divided by 12 is equal c to the power of 1, and that makes 3. And now I know that my equation is therefore y is equal to 12, 3, and x. Now this is given that we already knew what happened when the exponent was 0. But let's say we didn't know that. So I'll give you a more difficult question. Actually, it's going to be the same question. We're going to do it. Just add a page here. Hold on. Dual page. Okay. Supposing we had the same table of values, but assuming we didn't know that there was the 0, 12. Okay, supposing I gave you 2 points. So given 2 points. It's going to be a little bit more difficult and very important, how to find the rule of exponential. So supposing I told you, okay, I have 1 and 36 is my 1 point, and 2, 108 is my second point. So whatever, I had drawn this graph, and those were my 2 points. I have xy here, and I have xy here. So what you're going to do is you're going to, step 1, set up 2 equations. It's a system of equations. And I'm going to write it out like this. So y is equal to acx, and y is equal to acx. I'm going to replace the points that I know. So in this case, I'm going to use the 36 over here, a, c, and 1. And right here, I'm going to put the 108 is equal to a, c, and 2. So here are my 2 equations. And we're going to do a system of equations to solve. Now, I can do either or, but I like to put my bigger exponents on the top. So for ease, place higher exponent on top. You can do it both ways. You can set them up either or. So I'm going to set up the equation as 108 is equal to AC2. And you could do it in multiple ways. I'll just show you one way. Over 36 is equal to AC1. So now I'm going to solve by dividing. So 108 divided by 36. This makes 3, I believe. The A with the A cancels out. And now you need to subtract the exponents. Remember, when you divide things with exponents, the exponents get subtracted. So you're going to divide the coefficients, but you subtract the exponents. So I'm going to do C2 minus C1 becomes C1. And ta-da, there's your answer. Now, knowing that your C is 3, you write therefore y is equal to AC3. And all you have to do now is plug in one of the points and solve. So step 2, solve for A by plugging in one of the points. So you already know that 36 is equal to A and then the 3, 1. So 36 is equal to 3A, and 36 divided by 3 is equal to A, and A is equal to 12. Therefore, your final equation is y is equal to 12, 3, and then x. Ta-da! That's how you find the rule of an exponential. Now, I will post, I guess, questions from those, or you could do all the skill builders where you're finding the rules. We're going to talk now about what does this B thing mean again, and how are we going to solve this? Let's see. Okay, before I do that, I think I'm going to backtrack. Okay. So, last class we talked about the B and what does it mean exactly. So I'm going to just recap with a few word problems. So we have the basic function a, c, bx. Repeating, this is for word problems. So the a is going to be your initial value. We said the b is going to be your multiplicative factor. And that means things like double, triple, whatever. Double, triple. You might have percentages in decimals. Now, your B is a period of time. So I'll use words like every 3 days, or I might say something triples annually, or I might say monthly. I might say quarterly. I might say daily. Okay, and then your X is going to be your time. It's a unit of time. It could be days, it could be minutes, it could be anything. Okay, so quick example. New page. So again, if I said I start off with, I don't know, 20 flies in a petri dish, or fleas, I don't know, whatever they're called. And they multiply by doubling every 6 hours in a day. Okay, now it's very easy to figure out that the A, which is the initial value, is the original 20 flies, fleas, whatever. The C, I said the word doubling. So if something is doubling, then your C is going to be 2. Not a problem. I'm going to leave my B blank for now because we're going to have to talk about that. And next is my unit of time. Now, it's all about your perspective. If we're talking about days, then my unit of time is days. If I'm talking about hours, my unit of time would have been hours. But since here I talked about every 6 hours in a day, and my unit of time is days, you have to ask yourself how many 6-hour periods are there in a day. So this one has to be period. That means there are 4 6-hour periods in a day. It's almost like when sometimes you're given medication and they ask you to take it every 6 hours. That means you need to take it 4 times a day because there are 4 6-hour periods. Now, this is important to understand. It's often a source of confusion, and we're going to have to do a few more examples of these for you guys to understand. So Y is equal to A, which is the 20 flies, the C, which is the 2. Then you've got your 4 periods for the days, and that's what it's going to look like. So it's 4 times X. So then if I ask you, okay, so how many flies are there going to be in 5 days? Well, then you're just going to replace the X by 5. And that's pretty much it. So very important for that B. Now I'm going to give you another example. It's kind of the same, but this time I'm going to change the unit of time. So let me just go into the second one, dual page this. Okay. Second example. There are 20 flies again, but they double every 3 days. So in this case, I didn't mention anything else. I didn't mention hours. I just said they double every 3 days. So your unit of time is days. So your A is still your 20 flies. Your C is still 2. But now your B is 1 over 3 because your X is days. So your equation would look like this: 22 1/3 X, which of course you could also write it as 22X over 3. And that's how the equation would look like. So that's talking about the B. So let's look at some of the questions that are already written, and this I think is from page 308. You could find it somewhere in your Skill Builders number 10. I'm going to just make the page bigger. Just give me 1 second. Okay, of course, there we go. Okay, so in this question, they want us to calculate the number of years before the population of the herd reaches 100. So just look at the question. They've already written out the equation, and this is going to be practicing solving X or solving Y. So I'm almost done. I'm just going to do these 2 questions, and then we're done. So if you look at this question, it says the function R is given with 16, 2, and then t over 5 represents the population of a herd of bison, where t represents time in years, and r represents the population of the herd. Okay, calculate the number of years before the population of the herd reaches 100. So what are they asking us to do? Are they asking us to solve X, or are they asking us to solve Y? So if RT represents the herd, then they're asking us to solve RT, which is the Y. So RT equals to 100. So that means you're going to be solving for T. You're solving for the X. Now, the way they show it in Math Help Service is a little bit different, but I'm going to show you how I do it. So you can choose either method. So I'm going to place the 100 here in the position of the Y, or the RT, 16, 2, and then T5. So you're going to have to use logs. Use logs. So this goes with what I showed you in the second slide. Now, once you've done that, you're going to do, okay, so 100 divide by 16. Once you do 100 divide by 16, I will do that on my calculator. You'll get 6.25. So 6.25 is equal to 2t over 5. Now, once you're here, this is what's really, really important. This is where everybody's stuck. This is where you do the rewrite in a log. So remember, this is called the power. This one's the base. This one's the exponent. You're going to rewrite it so it says log base power equals exponent. And that's what we're going to be doing here on the bottom. So you're going to write log of the 2, which is the base. The power goes here, equals t over 5. And of course, on the calculator, this is going to look like this. So just by the way, log of 6.25 divided by log of 2. That's the calculator. Log divide by 2 log, and you should get 2.643 blah blah blah. I'll round it off. T over 5. And now I'm going to cross multiply, and I do this times this, and I get t is equal to 13.22. And there's your time in years, I believe. There we go. And that's how you solve it using your log. Moving on to the next question that I wanted to look at was this one here. Same concept. Wait, do I have any other ones? Nope, we're done. Okay, so in this one, Marcus invests $500 in mutual funds that increases in value according to function AT 500 1.035. So they're actually showing you that his initial investment was $500. The 1.035 is his interest rate, which we will discuss next time when I talk about compound interest. This is an interest rate of 3.5%. It's compounding and it happens twice, if you notice, twice in a year because the period is 2. So they've already written the equation, and the question is calculate the amount of time it will take for Marcus's investment to double in value. Well, what's double of 500? Double of 500 is 1,000. So they're asking you, when is it going to reach $1,000? Again, so you're going to place the 1,000 over here, 500 over here, 1.035 to x, and then you're going to solve by doing the isolation. So you're going to isolate the base. So you're going to divide this. By the way, you also could have completely skipped this step and just put a 2 in the beginning, because those of you who saw that was a double, that's what it is. Okay, so this is where people are stuck normally, and they say, what do you do here? When you're stuck, you do the rewrite. You write it as a log. Rewrite. So you're going to write log base 2. No, not base 2, sorry. My mistake. The base is 1.035. 1.035. The answer is 2, and the exponent is 2x. On the calculator, that looks like, so on the calculator, just a side note, calculator, it's going to be log of 2 divided by log of 1.035. That's what this is. Okay, you don't have to show that. You're going to do that on your calculator. 2 log divided by 1.035 log is 20. It's not going to be a beautiful number, but whatever. We make do. Now you just solve your x. So I'll just make this a little bit smaller. So now 20.149 divide 149 divide by 2 is equal to x. And your answer is about 10. So 10 is approximately x. And that concludes our lesson. I think I had something else, but I don't remember where I put it. Let me see. Yeah. I hope that has been helpful. Let me just go back and see if everything is here. I think so. Yes, it is. Okay. So I will leave you guys with some questions, and hopefully this was understood. And I need to quit time player. Quit. I don't think. Save.